Now that we've seen a basic example of how to use the law of sines, we're going to get into some more special circumstances that you could run into. Now, anytime that you're given two sides and a non-included angle, and if you recall, you may see that written like that, SSA, not with the A in front, obviously. A side, and a non-included angle. And if you remember, non-included angle means that the angle is not between the two given sides. What can happen technically is the length of one of those sides may not connect the triangle, and so you could have some issues with the definition of the triangle. Now, the possible scenarios that could exist are that there is no triangle, which we would consider no solution. You could have one triangle, or you could actually have the possibility of two triangles. Now, a lot of newer textbooks in mathematics will call this the ambiguous case, because they say that the solution is ambiguous based off of the given part. Basically, there are a few ways to tell if you're going to have one of those types of solutions, and so we're going to spend the next couple of examples going through the different possibilities of what type of solution you could end up having, determining the number of triangles that are available given two sides and a non-included angle. So as we're going through these examples, I've created a little table here, and what I would recommend to you is to keep this table in front of you and use as a reference. It makes learning these special cases a little bit more straightforward. And you can see here we use angle A and we use side A and side B. Now keep in mind, in any given problem, the included angle does not necessarily have to be angle A. It could be angle B or angle C, and the sides could be other sides. But you're just basically looking to see, is the angle a non-included angle, and is it less than 90 degrees or is it greater than 90 degrees? So as you're looking at this, you can see if it's less than 90 degrees, you have the possibility of there being no solution, one solution, or two solutions. And a lot of that is determined based off of the height of the potential triangle and its relationships to the given sides. And so we're going to look at specific examples in regards to this. Now, the other possibility is that the included angle is obtuse, it's greater than 90 degrees, and in that case you could have no solution or one possible solution. With an obtuse triangle, there is no possibility for two separate triangles, so keep that in mind. Okay, so with this in mind and with this little table as a reference that I would recommend keeping in front of you, we're going to move into some sample problems in the next few videos.